Oh, there, thanks. Oh, sorry. So it's abstract and symbolic in the way that it's like a canonical Nazi. It's not a specific exemplar necessarily. It's almost kind of disembodied from the context. And any arousal you might experience is somewhat removed from any threat of present danger, right? It's because of that temporal distance. And so you could argue then that the emotional meaning here is non-sensory. It's not coming from the bottom up, it's actually having to be inferred from the top down. What do I mean by that is that this emotional meaning really lies within a broader semantic network of ideas that are both positive and negative associations, right? You could think of the Nazi as being semantically related to World War II and to concentration camps and to propaganda, but it's also related to these other positive concepts like the formation of the United Nations, the Allies winning the war, et cetera. So I'm going to take a step back and just talk a little bit about construal level theory, which is a basis of some of the research that I'm currently doing. And construal level theory really talks a lot about this concept of psychological distance. And the idea with psychological distance is that as you start to remove objects that are being represented in space or time or socially or even in hypothetical distances, we tend to use more abstract ways of thinking about those. So the representations themselves become more abstracted as you create more physical distance or social distance, et cetera. And so this allows us to kind of have this interesting gradient of representational space. We can represent something very concretely and tangibly, or we can kind of fluctuate to this more abstract space that we're in. And this really facilitates thinking and planning for the future, even remembering the past. You know, we have these distant memories that we can kind of have more of a bird's eye view on them as opposed to this like embodied remembering or recollection. And we could even imagine counterfactuals. We can simulate experiences that have never actually happened. And so, again, the crux of this theory is that whenever you increase psychological distance, you therefore increase the tendencies to use more abstract means of representation. And those abstract representations would be characterized by getting a general idea or a gist or kind of the essential features of the situation. There also tends to be a greater focus on why versus how. So let's put this in context. So when you were planning to come to this event, you first saw the posting on LinkedIn or however you saw it on Meetup, et cetera. You might have thought about being in this space and the other talks you've seen here, and that's a motivating factor. You might have, got an inkling of maybe there's free pizza, thanks to YLabs, I guess, and maybe the connections and networking that's possible. You might also have just a sense of general connection to the AI camp community. And so these are all kind of motivating factors for why you would want to go. Why would you register for the event? So this is kind of high level. But on the day of, like this afternoon, it's a very different type of representational space. You have to rearrange your calendar. That's probably busy with meetings, et cetera. You might have to leave a little bit early if you're trying to get from Seattle and avoid the traffic jams, right? You have to think about what route are you going to take? Are you going to take the 520 or the 90 to get over here, et cetera? And so the representational space is a little bit more idiosyncratic at this more present moment representation. Does this make sense to everyone so far? Great. So this is a really ugly cartoon, but imagine that this cone is representing construals getting broader and more dissipated as we go. And we think about psychological distance increasing. So according to the theory, you could take let's say, a very idiosyncratic example. This is my specific phone that has a specific color of case. It has, my, screensaver on it, et cetera. But if I remove that in time or space or put it across the room, I might tend to think of it as just another category of iPhone. Take another step back, it's really just a mobile device more generally. See where this is going. And insofar as that, it's actually just another type of phone, really. And if I take another step back, I can just think of it broadly as a a form of communication, a device for communication. So I keep abstracting away as the representation gets further and further. And so if we think of this kind of graph network, let's just imagine this network is representing like semantic associations. Something like the phone and the gramophone are typically thinking of like a long distance between them. And if you were to vectorize this, you think these things are pretty far apart, right, in semantic space. Yet if I activate the concept of music player, well, the relative space is smaller. Does that make sense? So this is, again, a lot of these ideas came before the modern LLM, right? But the key point here is that there's a mistake to be made if you treat semantic distances as fixed entities. They have to be contextually driven. Like dogs and airplanes are far apart until I have to travel with my dog, right? And then that becomes very, very close in the terms of representational space. So I'm talking about psychology, not models, but hopefully you can see how these things connect. Okay, so going back to the dog and the Nazi, beyond the contents and the manner of depiction is what really influences the mental representation. So it's not just the objects that are contained in the image that are important, it's the manner in which we are depicting those objects. And you can see, like, you know, a cartoon duck Nazi has a very different evocation, even though it's also still a Nazi. And maybe if you had a classifier, just call it a Nazi, right? The smiling dog has a very different meaning space than the snarling dog. And so here again, this problem. So, you know, for our purposes, it'd be great if we could like eke this kind of information out of, let's say, a classifier. But if I run an image like this through Google Vision, for example, you know, it's going to tell me the objects that are contained, but it doesn't really encapsulate much of the meaning space of that image. And so these are very useful within a narrow case, but they also kind of fail to tell me much about like kind of the psychological space that this image is embedded, or what kinds of perceptions can I expect a user or a participant in an experiment to have from it, right? Okay, so now we'll talk about the actual project I'm working on. What we're embarking on here is to essentially norm a bunch of images. We have gathered around 2,500 images so far, and these are sourced from various, like, you know, open source photography sites and some of the repositories that my colleagues were working with. And within that, we've identified 18 different psychological classes, so to speak. So for every image in the database, we're collecting human ratings across each of these 18 separate psychological categories. And the human raters are providing a minimum of 15 ratings for every class and for every image. So that amounts to over 2,000 participants so far and over 760,000 individual ratings. And so from this, we have now normative distributions. We can look at the actual distributional characteristics for every class, for every image. And these classes were informed by construal level theory as well as other previous lines of psychological research. So what we're really trying to then suss out is not the objects that are contained in the image, but these kind of deeper, let's say, meaning spaces that these images lie within. So here's just a quick overview of the classes. We're thinking about things like embodiment, like do you perceive, like, to what extent does the image like is felt in the body? Does it have emotional content? Is there movement? Does it evoke a first versus a third person perspective, et cetera? I won't go through all of these, but just to give you kind of an example of what types of things we're looking at. And here's an example of a question on you know, this survey that we're actually asking. So in this, we're asking about animacy. Does it feel alive or not? And they would move the slider to like either anchors of inanimate or very alive. And this is getting transformed to a 100-point scale from 0 to 100, basically, where 0 would be inanimate and 100 would be very alive. So now what this allows us to do, if we take the same example of an image in our database, you know, we have perhaps labels we can get from a classifier, but now we actually have more like things like about the meanings, right? Its level of abstraction. Is it interesting or not? Does it evoke a sense of like conceptual complexity, et cetera? So now the next step, what to actually do with this data. So what we've been doing first is trying to see like what are the interrelationships across the images in the database in terms of the visual space that they're in. For this, we just used a pre-trained efficient net model from Hugging Face and taking that last invisible layer to capture the embeddings from that. And this is kind of giving us a sense of like the visual composition as well as some of the semantic information about the image as well. And then from that, we're just using a cosine similarity metric basically, so that you can see like, you know, on a scale of 0, 1, how similar are any two images in the database to each other in terms of that visual composition. The second thing that we've done, I've run all the images through a multimodal model called Lava. Has anyone here used Lava yet? It's pretty fun. Yeah, so basically it allows you to caption the image. You can ask in natural language any number of questions. I just asked to give a basic description and like capped it, I think, at like 256 tokens. And it does a really amazing job of telling you, you know, kind of in depth, like what are the contents of the image. And so from there, you know, having captioned all of these images, we then ran the captions through a text embeddings model through OpenAI. And therefore, we have extracted those embeddings as well. And so, you know, we just basically run the caption text through the embeddings model and get this text as vectors, essentially. And just like with the visual information, now we have both visual and semantic matrices of you know, cross comparisons across every single image of the database. And this is kind of an example of what that looks like. So I think this is working quite well so far. So here's my reference image, is this cemetery. And if I find a close semantic exemplar in the database, you know, it finds another cemetery. So far, so good. I think it's doing a great job of that. And then if I look at the visual match, it doesn't capture a cemetery at all, but it does seem to capture the trees, the fields, and notice the fence posts, the uprights are very similar in structure to the gravestones. So it appears to be doing exactly what we want it to do. So far, really, really great. And so as far as like next steps and use cases, you know, the end state of this ideally is going to be an open source repository for researchers to use. So after we've kind of finished collecting and collating the data, we'll be porting it over to an actual vector database, likely Zillus or something open source like that. And you know, the database would of course include the semantic and visual embeddings information, as well as the rating information and distribution characteristics for each image as metadata tags. And ideally would facilitate, you know, keyword search as well as reverse image lookup, as well as, you know, searching by any of those dimensions that we captured, 18 classes. So I'm kind of breezing through. I'm talking a little fast. Is everyone kind of with me so far? Hopefully makes sense. Okay. So I want to kind of just talk about a specific follow-up use case and something that I've observed that I think is quite interesting in the data so far. So I mentioned that we're collecting data that are relevant to construal level theory, and one is like the physical distance, and one is this perspective, right? So here's an example of a very close-up image is these shoes, and a distant image is this kind of like overview shot of the planet. The first perspective is kind of this image almost suggests for you as the viewer to take the perspective of being on that trail, right? Versus the third person perspective, it's like you're looking almost like this bird's eye view over the guy's shoulder. And these are actual exemplars from the database. So this is great. This is exactly what we want to see. However, we have certain images that when they're taken from this very hyper close perspective, there's a tendency for people to actually rate them more likely as being third person instead of first person. even though you could argue that this is more of a first-person perspective. And so that seems kind of weird, right? Like, why would that happen? And if you're interested in kind of like reading a little bit more on this, I'll just put this up here as I talk. So this is something that we predicted in a recent paper. Does anyone here practice mindfulness meditation? Just a couple of people. Is anyone familiar with superrealism as an art form, like Chuck Close and the superrealist, hyperrealist painters? Okay, so superrealism is like this movement that kind of came in the 70s. It was like a response to like ultra modern abstract art. It was like kind of reversing gears and like, hey, let's do something like as realistic as possible. So these are like giant paintings that are actually like from a distance indistinguishable from photographs, like just so photorealistic, but they're, you know, hand painted. Just amazing, amazing stuff. And sometimes they'll take it to an extreme, which is like let's say you got a 20-foot by 10-foot canvas that's like the head of a nail, right? But it's like, and they'll take several photographs to get it from where it's in focus across multiple different views and paint it like that. So it's, no matter how you look at it, it's in focus. So it's like this weird presentation of something that you would actually never really encounter in nature. Right? So even though it's realistic and even though it's really close, it's also kind of deviates from your normal day-to-day perception of the world. And the reason I mentioned mindfulness is mindfulness, you know, the early practices really encourage you to be mindful of like low-level visceral sensations, right? Your breathing, or some mindfulness exercise like put a raisin in your mouth and savor it and move it around and really dig into all of those senses. Well, who does that? We don't do that, right? That's kind of a departure of our normal, let's say, day-to-day simulation of the world. And so we argue that distance and construal don't always go together, that there's actually these kind of orthogonal cases where they might depart from one another. And this might be where they kind of start to violate someone's, you know, day-to-day modus operandi or mode of simulating their environment and their world. And so I think some of these hyper-real images, right, you don't usually get down and have that kind of like 2 inches from your nose, super in focus view of a banana, right? So it even though it's close, it encourages abstraction. It encourages to kind of like almost be disembodied in a sense. That's a theory anyways. And so here's an example of an image, another kind of hyper close image in the database. And this is the distribution of ratings for distance. You can't see the numbers here, but it's on the 100-point scale. So you see like the lower numbers to the left. Pretty good agreement that this is, in fact, a close image. That's exactly what we would hope and expect. However, when we look at the perspective, there's very little agreement. You see it's kind of more of a bimodal distribution where some of the people are like, nope, definitely first-person perspective, no question about it. Other people are kind of in the middle, and then a bunch of people on the right are like, no, I feel more third person. So there's some weird, wonky things going on with these really close-up images. And so what I would like to do is kind of pre-register this as a new experiment, or not really an experiment per se, but more of a study. So the idea would be to gather images that vary across different vantage points, from like far away to extreme close-up, and to make sure that they're all in the first-person perspective. And then so this is now we have a subjective measure of distance that we would get from the ratings. But I'd like to try to find some kind of objective way of classifying that distance as well. And if anyone has maybe like an autonomous driving pre-trained model to recommend, I thought that might be a good way to try to quantify distance. So the prediction here is that the relationship between perspective and distance should be tighter for these far to medium close images. But once you get like super close, that you see those relationships start to break apart. And I think that would kind of fit in with some of the ways we're thinking about how construal theory works in the mind, essentially. So Yeah, so that's kind of where we're at. That's all I had for you today, but definitely thank you very much. Definitely reach out if you're interested in this kind of work. You can see my portfolio site here. I'm happy to connect, happy to collaborate. If you are interested in any kind of weird mad science types of projects. So I'll leave it there. Thank you.
Anybody have questions for Dana?
Yeah.
Great talk, super interesting. I'm just very curious as to why did you use Lava and not GPT-4V directly?
I didn't have access to GPT-4 yet. So this isn't like the end all be all. We'll probably play with a few different models and see how they line up. But yeah.
Cool.
Yeah, I think Lava was the first one. And, incidentally, I was able to run it locally on this amazingly as a quantized model, which I thought was pretty interesting. Yeah.
Awesome.
Oh, sorry.
This one's more like kind of related to like the sciencey part. Do you think that lived experience contributes at all to the abstraction? Like, because when I saw the banana, I kind of was like, what you said, like, who looks at a banana that way? Like, your eyes have never seen a banana in that focus. So would you think that, I don't know how you find this, someone who's never seen like a hummingbird from that close or something, is it also to a degree of like, I don't know what that is? So like your sort of sense of abstraction is so far removed? Or do you think it's exclusively based on sort of the visual aspect?
No, I think it's definitely an interaction of perception and sensation, right? So you say the vision's a sensation, but perception is going to be guided by prior experience. And so while we can't predict any given person's reaction to any image, by collecting multiple ratings, we get a distribution. So we can kind of try to predict the average or the average response. So, of course, any given participant is going to have idiosyncratic relationship with any given image. But on the whole, we should be able to predict, like, let's say the negative emotional images are going to, on the average, induce a negative emotional response, regardless of someone's prior experiences. Does that make sense?
Yeah.
Yeah. There's a couple more. Yeah.
How did you choose the categories? It looked like you had roughly 18 of them. And also the example that you shown was a continuum between something that's very alive and something that's not. For all of those categories, is it like that where you could really describe it as one word and then kind of apply a float value to it, a continuous?
Yeah, it was difficult. So, I had several collaborators and a lot of different interests to try to satisfy with this, and a lot of different theories that are coming together on that. So we went through a lot of iteration for deciding the categories and also the text of the question and the appropriate anchors for that. So that one word anchor. So there's a whole paragraph of like more descriptive text that the participant sees to explain what we mean by animacy, for example. Some of my collaborators and I are also in a very different field of research with like more non-traditional psychology, more parapsychology. So researching things like remote viewing and non-local perception. And so some of the characteristics like numinosity is, anecdotally is a big factor for people's remote viewing success. Motion is a big one, and animacy as well. Some viewers are better at picking up like things that are alive versus not alive. And some are more driven by like construal level theory. So like the distance perspective, the social aspects of the image. An image can be social because it's like got a phone in it, or it can be social because it has people in it. So there's a lot of different characteristics of that as well. So does that answer your question? Does that make sense? Yeah, cool.
Let's take one more question.
I'm just wondering if your hypothesis proves to be correct, what is the real world implication or application of this?
Yeah, so one of my motivators when I started this project was pre-GPT. So I thought that it was, you look at language models and even like image classifiers. And it's really there's this big gap between what's there and what's inferred or what's meant, right? And so going back to the Nazi image, there's nothing in that image itself that a classifier is going to say like, oh, like it's just going to say soldier. It doesn't necessarily have any broader context. The meaning actually it lives outside of the image. Now GPT is like amazing at like bringing in all of that other semantic association. At the time when I was really pushing for this, I thought it would be useful even in both language and image classifiers to start to try to understand what's the meaning space of something, not just the objects that are in it or the words in the sentence, right? And so really playing on this idea of semantic space as not being a fixed vector, but that it's a fluctuating vector depending on surrounding context. So while there's been a lot of strides made, forward progression in terms of like relevant models and such, there's still a need for this as far as like a stimulus set or data set for experimentation. So in the lab, like the work that I was doing was emotion regulation. So we would show people these negative images, have them let their emotions unfold naturally on some trials, and on other trials they would try to recontextualize or reappraise the image to think about it differently to feel better. So if you saw an image of like a car crash, you might think like help is on the way, et cetera. And so our theory, or my theory, was that images like the dog are more difficult to reappraise in that space because the dog's, all your arousal is telling you should run away. Like if you came across a Doberman ready to bite you, you shouldn't be like, oh, how do I feel better about this situation? Like, no, you got to move your body, right? But if you failed the test, right, then it's not good to like catastrophize it or perseverate on it. You should try to recontextualize it so you can do better the next time. So there's this kind of ecological fit. And that is lost in just valence arousal vectors, right? We need to think about where's the emotion and the meaning of these images really lie, and what strings do I have to pull in an emotion regulation context. I'm happy to talk with anyone after too, if
yeah. We have a place until 8 o'clock, so we can break up and then ask questions and so on. But one last question.
All right, sounds good. Great talk, Damon.
Thank you.
I had two questions actually. The first one might be a little bit longer, so I'll lead with that. So you mentioned on one of your beginning slides how you're extracting the last invisible layer or the last but penultimate invisible layer. And this kind of ties into the first question that was asked. Do you think GPT-4 will enable you to do that? I'm assuming this is because this is an open source model, you're able to extract that. So could you talk more about that? Like, how do you extract that? What is the customization do you have in that?
Yeah, so the process is really easy. It's just an efficient net that I got off of Hugging Face, and you can just specify the layer that you want to pull the embedding, and you just pull the embeddings instead of pulling classes. But since it's a later layer, my understanding is it's kind of convolving both visual and semantic information. So what would be interesting, and one thing I would plan to do is to try to pull earlier layers. Because if you think like how a model represents even like visual cortex, like early vision is like lines and orientation versus later it's like more semantic processing. So I think if you wanted to get more strictly just like composition and less meaning, that maybe those earlier layers might be better at that too. So I do want to.
Is this something possible with GPT models? Can you do this on GPT?
Yeah, so it's hard to keep up, right? Like I said, like I've started doing stuff like this is a few months old, and that's may as well be 10 years old in research terms. So I'm not sure. I haven't played with the GPT models as far as visual classification, more for the semantic stuff.
Okay, the second question was about the use case that you mentioned about reverse image search. How do you plan to compete with, say, like a Google reverse image search? Like, what is your scope of what you're planning?
Yeah, that's not really to compete. It's more like if you, let's say you're running an experiment and you want to get images that have these ratings for your experiment. Like, hey, I've got an image of let's say a cat, and I want to get other images that are like this, but that vary in terms of abstraction or vary in terms of emotional intensity. That can do a reverse image search, but also bookend that with like the variables of interest, et cetera. Does that make sense? So it's really just to leverage this data set for other researchers. We're not competing with anyone per se, really. Yeah. 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 Cool. Like I said, I'm happy to talk with anyone else that has other questions, but thank you very much. I appreciate it.
Thank you very much.